We're live. All right. And I can minimize this because Zoom doesn't actually pick up the camera. Today's date is Thursday, October 22nd, 2020. 3-8 Analytic Analysis. We're doing the last lesson of our unit. Where's F concave up, concave down? Where are the inflection points? We're doing everything that we've ever done, 3-6, 7, and 8. All in this lesson. So as a review, what do we do for just the F prime test? So basically, tell me, what did we do yesterday? First step, objective, sorry. Objective first. I think Fiona's up. Fiona, go for it. There it is, okay. So kind of same thing without a graph. You guys are probably used to this pattern. Fiona, what's the first step with the F prime test? X-axis. I'm going to do it off to the right-hand side because there's going to be a ton of things that I have to label. All right, so it goes on and on forever and ever. I label it. That is indeed our X. Okay, Andrea, what are we doing next? There they are. So find your FCVs. What is the definition of critical value again, Andrea? Prime equal to 0 or D and E. Good to memorize. Okay, that means we need to find F prime. Teflon, you're up. Find F prime. It's 4x. There it is. Chris, what are we doing with Teflon's derivative? Okay, so the definition of FCV is you set F prime equal to 0. So here's F prime, 3x squared plus 4x, and I'm going to Chris. Again, the definition is you set F prime equal to 0. Well, here's F prime. F prime is 3x squared plus 4x. So I will set it to 0. All right, you're still doing this though. So 3x squared plus 4x. How do you solve that, Chris? You could, yeah. It won't lead anywhere, and I'll show you why. So 3x squared is equal to 4x. Then what would you do? Yeah, you're kind of stuck. So my hint to you is factor out something on the right-hand side. Yeah, so factor out an x, and you're left with there it is, 3x plus 4. All right, we'll hand this off to Fiona. Thank you, Chris. Fiona, solve from here. X. Indeed, yep. Okay, so I'll help us out. Let's go ahead and graph these. I'm going to say negative 4/3 is there. We'll say that 0 is right here. We'll label those as well so we don't confuse those for the test points. That is our critical value and our critical value. Andrea, what do we do from here? Yep, which ones do you want? -2, perfect. Which one is the easiest out of all three of those to do? 1, okay, let's plug it in to, again, the factored form would have been easier to plug into right here, but you can plug into here. It's gonna be the same answer either way. I'm just caring about if it's positive or negative, and it is positive. So I'll come underneath this and say that's a positive. And then if you guys remember the trick from yesterday, you don't need to keep plugging it in anymore. Notice that in the factored form, this is x to the power of 1 3x plus 4 to the power of 1. It will switch signs every time it jumps over the critical value corresponding to 3x plus 4. It will change values every time you hit the critical value corresponding to x. So since those are the only two critical values, it will change signs. This will be a negative. And it will change signs again. This will be a positive. Teflon, what does that mean in terms of f increasing and decreasing? Yeah, sure. Give me the definition. What is f increasing? Yeah, f prime is positive. So left of negative 4/3, is that f increasing or f decreasing? F increasing, and then it flip-flops over and over again. And this one is therefore, and I can do the last one for you. That one's f increasing. Okay, and we come down here and let's start labeling these things. We found a bunch of stuff so far. Our critical values were at a negative 4/3, and 0. I should say x is equal to those numbers, sorry. So CVs is x is equal to negative 4/3 and 0, so comma 0. F is increasing on what intervals, Chris? Yep. Zero to infinity. Perfect. Fiona, can you turn that into inequality notation for us? There it is. Fiona, can you do the rest of this for f decreasing as well? Four thirds to 0. And inequality notation as well, please. Less than 0. Perfect. That's the first half of f prime test. There's still other f primes because these definitions have f primes. By the way, this is a perfect time to go through all these definitions once again. Let's just kind of go rapid fire here. Andrea, f critical value is f critical value definition equals 0 or D and E. Teflon, once again, f increasing. Chris, f decreasing. 0. Fiona, f relative extremum. Sign change. F maximum, Andrea. Positive to a negative. And Teflon, f minimum. Negative to a positive. Perfect. I know we've written them down like 20 times now. Hopefully we'll remember them all the way in May when we take the AP test, right? All right, so we know the relative extremum is a f prime sign change. Look at our f prime. The signs are down here. So, Chris, what x values do I have f relative extremums at? Yep, it's both the CVs. So we'll say x is equal to negative 4/3 and 0. Thank you, Chris. All right, Fiona, where's the f max? Where's f min? Yep. There it is. So we can come up here and we can relabel these things. This CV is an F max, that was an F min, and both of them were F relative extremum. You don't need to come back and label them if you don't want to, but I just want to have a complete set of notes if you need to come back and look at these a month from now and be like, oh, I totally forgot how to do that, and that one's going to be recycled on the test. Okay, now it's time for our new material, the F double prime test. So I know that we've already drawn one line. We're going to draw a second line because otherwise it's going to get too hectic on here. You're like, was that an inflection point? Was that a CV? Was that F increasing? Like, it's going to be so messy. You need to have a second line. So make our second x-axis. Second x-axis, and I'm going to make it on the right-hand side because I need the left-hand side to do some math. So on the right-hand side over here, a new x-axis goes forever and ever, goes forever and ever. Label it x. Okay. I'm going to relist Teflon's derivative. She said it was 3x squared plus 4x. So I'll say f prime, oh, what happened there? F prime of x is equal to 3x squared plus 4x. Now we need to find the second derivative because it's the second derivative test. So I now need to say f double prime of x is equal to, and let's see, who was the last person that did f minimum? I think that was Fiona. So Andrea, f double prime, go. 6x plus 4. And what am I searching for? Let's come down here. I'm searching for where the function is concave up, concave down, and inflection point. Again, kind of rapid fire. Let's label these definitions. Teflon, f concave up. Greater than 0. Chris, f concave down. Less than 0. And Fiona, f inflection point. Sign change. And notice that all of these are dealing with f double prime, and that's why we call it the f double prime test. And we've already found f double prime. Thank you, Andrea. Andrea, again, I need to find where it's concave up, concave down, inflection point. I need to basically find it's kind of like the critical value before it's the best way that I have for the terminology is a potential inflection point by setting it equal to 0. So can you do that for me? Equals -4/6, which is -2/3. So we'll go ahead and mark that on our number line, -2/3. And there's nothing that we can really say here. We just know that is if you want, you can say it's a potential inflection point. Notice I gave some room because we might need to write something else, or you can say something there. Yeah, so it's a potential inflection point up to this point. But we need to actually test some points to the left and right to check if it's positive or negative. If it switches between a positive and a negative, if it has a sign change, then we can confirm it's not just a potential, it is in fact an inflection point. So I need a point to the left and right, Teflon. What do you want to check? Yeah, so 1, -1. Yeah, so Teflon, go for it. You're plugging into the second derivative. Yep, when you plug in -1, it's negative. When I plug in +1, I get a positive. And again, the same trick applies. Look at the power of x. This is a power of 1. That means it's going to switch. I could have told you right from the get-go, right here, oh yeah, it's definitely going to be an inflection point because it's to the power of 1. It's an odd power. So from there, we can confirm, I should label this now, this is indeed an inflection point. I'll just cross off potential inflection point. It is an inflection point. I can say the inflection point is at x is equal to -2/3. All right, Chris, we're ready to start labeling f concave up and f concave down because the second derivative over here is negative. It is less than 0. So that is the definition of what? Is it concave up or concave down on this interval? Yep, so we'll say concave down, and then over here, concave up. So Chris, do the first interval f concave up, both both interval notation and inequality notation. We'll give Fiona the concave down notation. So F concave down is everywhere to the left of negative 2/3. How do I say left of negative 2/3? Not -1. -1 was just a test point. Can you say it again, Chris? Can I say less than negative 2/3? You don't have to do F double prime, it's just X, because still this is talking about the X coordinate. So you say X is less than negative 2/3. And then how do you do that in interval notation? Between what and what? Negative infinity. Isn't what one? I can barely hear you over the fan and the mask. Can you speak a little bit louder? That is concave down. I am sorry. Yeah, that is concave down. I'll go ahead and label that here. Sorry, Chris, for the confusion. X is less than -1. And how do you say between what and what for the interval notation? That's extra credit, by the way. Log it. So, Chris. Yes. So many mistakes. Yes, thank you. Yeah, log them. It's lots of extra credit. If you found it before I went, then you get the extra credit. How do I say everything left of negative 2/3, Chris? Negative infinity to negative 2/3. Yeah, exactly. Thank you. And then Fiona, concave up. Perfect. And interval notation. Infinity. Perfect. There it is. All right. I don't want to do another of these because they're too long, but I do need to give you some additional tips. And that is the same exact thing. So you guys should be able to really knock this out of the park. F of 5 is e to the power 5, and e to the power 5, is that positive or negative? It's positive. It's always, always positive. What about f of -10? I don't even care. Like, yes, obviously it's f to the -10, but is that positive or is it negative? It's always positive. Fill in these from a few units or a few lessons ago. E to the power of x can never be negative, nor, shout it out, 0. Exactly. It can never be 0. It can never be a critical value. It can never be a potential inflection point. And if I have something out in front of E, that will always be the sign of A. Exactly. If A is negative, then this whole thing will be negative. A is positive, it will always be positive. All right, that's the end of the notes.